Okay. Are we ready? We are on page 7. Okay, so we already talked a little bit about polynomial functions, right? Polynomial, we have one or more terms. And when it's in standard form, we want them in descending order. What's descending mean? Biggest to smallest. So it would be like let's say x to the 4th plus 2x cubed minus x plus 1, right? It's the degrees go from biggest to smallest, okay? Now, the coefficient of the term with the largest degree, that's called our leading coefficient. I think there was a question on the first assignment. Yeah. So in this case, the leading coefficient would just be 1. And obviously we already talked about greatest degree. That's the degree of the polynomial. So here we have an example.
Wait, what is the degree here? It would be 4?
Yeah, so we have a 3, 2, 4, and then technically that one has a 0. So the degree is going to be 4, and the leading coefficient is 3. So just be aware, this is not in standard form. So if I ask you to put it in standard form, we would rearrange it. That wasn't the question here, just asking for degree. Okay, function notation. Let's review. So, right, f of x. F is just the name of the function. So if I'm evaluating, we substitute in x, okay, with what's in parentheses. Make sense? Mm-hmm. Sometimes it helps to rewrite the equation. Instead of x, I just put parentheses in each one. Okay, because we don't want to forget to take care of negatives and like foiling. So here, so I have a plus 1. So I have negative a plus 1 squared, right? Because I'm replacing a plus 1 with x, plus 2 times, instead of x, I'm going to replace that with a plus 1, and then minus 1 at the end. Okay with that? Okay, order of operations says I have to take care of my exponents first, but this means a plus 1 times a plus 1. So what's a plus 1? Be careful, because
squared plus 2a plus 2 plus 1.
Plus 1, right? So a plus 1 times a plus 1, we have a squared plus a is a plus 2a times 1, or plus 1 times 1 is 1. Yeah. Yeah. Okay, next. 2a plus 2 minus 1. I would recommend not skipping a lot of steps here, because you can easily make a mistake with negatives and positives. Now that negative out in front, I'm going to distribute, and then we can just combine all like terms. Make sense? So that's going to be negative a squared minus 2a minus 1 plus 2a. Are you okay if I just combine that to make that a plus 1? Okay, is there anything I can combine with a negative a squared? No, so I'm going to leave that.
No, that's the answer. Yeah.
Ah, because what else happens here?
Everything else like cancels out.
Yeah, negative 2 and plus 2a cancel. And here we had a negative 1 and a plus 1. So just out of coincidence, everything but the negative a squared canceled. Otherwise, right, we would have more terms here. That's okay. That happens. How about the next one?
Oh, yeah.
Okay, here's what I would do first. I would figure out.
Distribute the 3, right?
No, distribute 2x.
Let's figure out f of 2x first, and then multiply everything by 3.
Oh, that works.
Yeah.
Absolutely. Let's take care of that 3 last. take care of the f of 2x, and then we'll multiply by 3. Okay, so everywhere I see an x, so I have a negative,
2x squared.
and then I'm going to put 2x squared plus 2 times 2x minus 1. Remember I told you it's a good idea to put whatever you're substituting in parentheses because you don't want to forget to distribute that. So what do we get from here? So that'll be a negative 4x squared plus 4x minus 1. Okay, now let's do... Okay, well, what's 2x squared? You would square the 2 and square the x, so that would be 4x squared. And then there's a negative in front, right? So negative 4x squared. 2 times 2x is 4x, and then minus 1. Okay, now we're just going to multiply everything by 3, so...
Negative 12x squared plus 12x minus 3.
Perfect. Okay, so when there's a number in front, I strongly recommend figuring out what the function is first and then multiplying everything out. Does that make sense why I kind of broke it up into those 2 steps? Listen, you don't have to do it that way, but sometimes students will start multiplying too early and it just messes everything up. Yeah? Good? You okay, Ari? Just get it right in on that last part. Okay. All right, the next page is on different types of functions. Remember them?
No.
No. Remember anything?
No, I remember that. Yeah.
What's that?
This part's
Oh, this was the easy part. Okay, so we could go through this pretty quickly. Oh, easy. Oh, I
You
have
see,
to
like start off like a little, and then it goes.
Yeah. Well, you know, that's the nature of math. It starts, you know. Doesn't it usually start off easy and then it gets harder and harder? No?
Oh, actually, never mind. I remember this stuff.
You don't remember this stuff?
I remember.
Okay, constant means it's just a straight line. A linear function, y equals mx plus b. Quadratic is with an x squared. Cubic with this an x cubed. Don't worry about these names, but you can have any kind of degree, right? Now, do you remember how the end behavior looks?
If it's even, then they end
Even,
in
they're
the
both
same
up?
direction. No,
Good.
if it's even,
Even if it's positive, both up,
If it's even negative,
Even
both
negative,
down.
both down.
both
And
down,
then odd is the
It goes
which-
this
the
way.
which-
and this way.
But if it's a positive leading coefficient, then it goes up, down, right?
Yeah.
And then if it's negative, it goes down. Right?
Yeah. Good.
Oh, no, positive goes down to up.
No, it's up and down.
No, it goes down to up. Don't argue.
You mean like it goes down to the left, up to the right?
No, it's like,
Or down, you mean like this part goes...
no, just like from down.
You're saying it's.
Oh, I'm always thinking, yeah, but you should always think left to right.
Yeah.
Yeah, kind of.
So how do you remember?
What's the question?
Oh, no. I have
Okay.
the same question, actually.
What's what question? What now?
No, it's this. Wait, can I try this one? Actually?
Okay. Yeah, Max, give me a sec. So let's see what we want to ask. We want end behavior. We want odd or even degree and the number of real zeros. Okay, Max. So should we do end behavior first?
Sure. Okay, so as x approaches negative infinity, y approaches infinity, or f of x approaches infinity.
It doesn't matter. If you put y, that would be fine.
Alright, and as x approaches infinity, f of x and y also approaches infinity.
Good. That's end behavior. Okay. Is it an even or an odd function? Good. Even function.
Positive.
Number of real zeros.
There are 4.
1, 2, 3, 4 zeros?
I do write that twice. I know it's different, but why?
Okay, so you always need x approaching negative infinity and
Oh,
x
yeah.
approaching positive
remember that.
infinity. It's this part that's going to change depending on the end behavior. This is going to be the same for every single end behavior. And we said it's even.
Does
and
the
4 zeros.
the degree
Let's
of
just
the
say even
function,
positive.
like the amount of zeros depends on how big
Okay.
the degree of the function is, right?
So, not okay. I have no idea what the degree of this function is.
It's not
It
4.
looks like 4, but technically it could be anything 4 or greater as an even. This could be an x to the 6. It could be an x to the 8. It could be an x to the 10. We don't know what's going on. We don't see the rest of it. We could have. You could. Yeah. So it's like you can't trust based on the turns. So, for example,
Would you say it's even positive? You should say
right.
minus.
Like if I say if I just did x to the 4th, x to the 4th just looks like a skinnier x squared. It only has 1 0, but it's an x to the 4th function. So this could be an x to the 4th, but it could also be an x to the 8th. We just don't know. But it has to have a minimum of an x to the 4th because you talked about turning points. Did you talk about turning points?
State the number of real zeros. There can be more real zeros than.
No, well, based on this, that's all we can see. There could be more to the graph, but all of what we can see is 4. Okay, how about the next one? We have end behavior. So as x approaches negative infinity, what does f of x approach? Negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. Okay, even or odd? Odd.
Wow.
So anytime they go opposite directions, it's got to be an odd function. Okay, if they're both facing up or both facing down, it's an even function. And how many zeros? 3 zeros. Ari, did you have your hand up? You're good though? Okay. Yes. What did anybody hear what I said?
No.
I did.
Okay, Rowan didn't hear what I said.
When they both
When they both go up, they're even. They go or.
If they both go up or both go down, it's even. When they go opposite directions, it's odd. That's the easiest way to think of it. Okay, end behavior without the graph. So what do we want to look at? The leading term, the largest degree, and then the coefficient. So if it's an x to the 4th, it's even. So it's either going up or down. Even negative, so it's going to go like that, that. So, well, no, we're just going to fill that in then. So as x approaches negative infinity. Good. Did you guys write negative? Did you write y instead of f of x?
No, we watched.
Oh, okay. Not at all. It means the same thing. Oh, and actually, I just realized this says g of x. So as x approaches positive infinity, well, because that's it's not named f of x, it's named g of x. Listen, if you want to put y, you can name them all y.
Why I always go slanted?
Yeah. Because if we look to the left, to the right, doesn't matter. It's all just going to negative infinity.
The next one's odd.
This one,
Odd even.
it's odd with a positive. So it's going to go up to the right, down to the left.
Negative, negative, and positive,
So negative,
positive.
negative, positive, positive. We don't have to answer any of that stuff.
So,
No, we'll do it on the next page. We wouldn't be able to do that without a calculator. Well, the zeros. Well, how are you going to find the zeros?
Because if it's a 4, it's going to go.
No. Can you factor that?
You need calculator.
Don't you just look at the exponent? Or no?
No.
Oh.
Okay, just because it has a 3 doesn't mean it has 3 zeros.
Oh, yeah, because it could go like below the.
Yeah. I just gave you the example. This is an x to the 4th, but x to the 4th just has 1 0. It's right here. So just because it's x to the 4th doesn't mean it has to have four zeros.
How did you see the?
Do we have class Monday?
No.
No, it's Maroon Week. What's that, Rowan?
How do you tell it's positive and negative? A line right there. 2 lines.
How did I know? Because it's an odd function with a positive coefficient. So it's going to go up to think about like what does x to the 3rd look like? It looks like that. So this is going to model that same behavior.
Oh, I see. I can memorize that.
Yeah. All you have to do is think of x squared and negative x squared, right? You know what positive x squared looks like and negative x squared. And you should know positive x cubed and negative x cubed. And that will follow with any kind of function that has odd or even like that. Okay, calculators. Do we have them? Anybody charging theirs over here?
Mine's at home. But I remember how to do it.
Okay, so Sam wants to make t-shirts to raise money for a school fundraiser, and they determine their profit function is there. Okay, let's graph the profit function.
It's just a function, right?
Okay, so
After this bill.
I'm going to go to the scratch pad. Oh, you forgot it.
No,
Oh, you? Okay. So we're going to type this in, negative .05x. Oops. What is that, squared?
That's dead.
Ooh,
Do we do we need a calculator for the whole thing?
yes. Do you have a charger at home?
Yeah, I think so. I'll just leave it in the dark.
Okay, when I press graph, what happens?
It graphs.
Well, it graphs it, but do we
Wait,
see
what's the
anything?
graph? No.
You have to like zoom out. You have to find a reasonable view.
We do. We do. So, what do you think?
I just zoom out.
You want to just zoom out?
So much easier.
Okay, so let's go zoom out. Oh, okay. There we go. That looks okay. So what is that viewing window? I can just go here to my window settings. Oh, that's a weird.
I don't even see the graph.
Did you zoom out enough? Just keep zooming out until, and you know you can drag your graph, right? You know, it is. It's got an x squared. Not just that, it has a negative x squared. Okay, so once you kind of zoom out, you can just press the window settings. So what you guys might have a slightly different answer. What did you have for your x minimum?
Negative 286.
Whoa. What did you guys have?
X
Mine
minimum.
just bugged out.
I have negative 286.10006. 289.308.
God damn, God.
This case, it's like 1,000.
Yeah. What?
Another
Oh, okay. I guess that'll work.
Is he on degree?
Oh, if you like zoomed way out, that's why. You know what? I would say zoom a little bit further in.
back. Let's see that.
Well, yeah, it's not that.
Okay. This is a little back. Did
No.
you get a good window? I would zoom in a little bit more.
Sorry, I got it.
I'm at X
But
minimum
maybe-
is
yeah,
not
but
is
it
like
is
negative 36.
Okay,
So
negative
how does it
36.
change?
It's okay. Listen, you can have multiple different viewing windows. I'm going to say mine is negative 6. You have negative 36. That's fine. My X maximum, I put, it looks like 88. Again, these are approximations. You can have a different viewing window and it still work. And then a Y minimum of negative 24.
Your numbers
I
are
don't
so
think we
much
did
smaller
this.
than mine.
Is your graph really tiny? It isn't? Well, that's fine.
I like 71 though, and 88, and then like 52. And
That's okay. You still have a good viewing window of your graph. Because I think mine was like 37.
What's the
Okay.
relevance of the viewing window?
Okay, so in pre-calculus, we start, well, not just pre-calculus, in algebra 2 and in pre-calculus, we end up graphing some really crazy graphs, and you want to be able to get a good viewing window pretty quickly. And so sometimes you have to zoom out and zoom in, but you want to be able to get the whole picture.
Okay. Also,
Okay.
for the Y max, what if it's like a decimal?
That's okay. I just rounded to the whole numbers for mine.
Can I also do that?
Okay, approximate the zeros. So we know there's two different ways to do this, right? We could do the trace or we could do analyze graph. Why don't we do that?
Zero. 21.
21 and a half.
That's one of it.
I got 20.8.
20 point. Let's see. Did you do trace?
I did. And the other one I got like 69.7, but it's not zero. It's like 9.
Oh, that's okay. So 20.8.
Oh, never mind.
Is that what you guys got?
Yeah.
I got 21 and a half.
How did they?
I don't
Did
know
you
how-
miss something?
Because you're not fully out of zero yet. You have to go one more zero.
But it said zero.
You might have typed something in slightly wrong. Maybe that's why your numbers are so different.
And then I got 72.
72.2.
Oh, yeah. I did type it wrong.
Good job.
Okay. So the last question. So these are the zeros, and I want to have a range of T-shirts to sell to have a profit. I can't sell 20.8. I have to go between 21.
21 and 73.
These people are really bad at selling t-shirts.
I agree. 21 and 72 T-shirts. Okay. Did you guys finish off the Twizzlers? Excellent. I have to
I
go.
had a lot.
Well, sometimes, you know, I'm awfully generous. I bring extra snacks for my advisory because I know some of the snacks that the advisory don't.